Welcome back. We're still looking at solving absolute value equations. We've got this 4-step process that we're going to use, but I want to look at some special cases. So here I have the absolute value of 4b plus 1 plus 8 is equal to 0. And this is a special case. We'll find out why in just a minute. But I am going to go ahead and solve this. So I get the absolute value. So I'm going to first start by subtracting 8 from each side. So that gives me 4b plus 1, the absolute value, is equal to negative 8. Now, I'm going to stop right here. So I've done step 1, which is isolate, and I could just move on to step 2. But what I want to go back and remember is my definition of absolute value. So an absolute value is the distance from 0 on a number line. And this is always a non-negative value. So that means that the left-hand side is going to be a positive number. Can a positive number ever be equal to negative 8? And the answer is no. We will not be able to make a true statement. We're looking for a true statement. There is no value of my variable b that will make this absolute value a negative number. So this is no solution, or there is an empty set. Okay, so there's no solution. There's no value of my variable that can possibly make this a true statement. So anytime you get the absolute value is equal to a negative number, there's no solution. You can stop right there. If you had continued to solve this problem and gotten an answer, what you would have gotten is that if you had solved this, if you had separated this out into 4b plus 1 is equal to negative 8 and 4b plus 1 is equal to positive 8 and solved these, you would have gotten b is equal to negative 9 over 4 and b is equal to 7 over 4. When you checked these, both of them would have given you statements that aren't true. So you would have found that they weren't, that there was no solution anyway. But anytime you get an absolute value is equal to a negative number, you are welcome to stop and say that's impossible. It is no solution. So that's our first special case. For our next special case, I want to look at this problem. 2 times the absolute value of x plus 1 minus x is equal to 3x minus 4. Now in this problem, what makes this one special is that I not only have an absolute value with a variable inside, but I have my variable appearing in other places in my equation as well. We're still going to follow the same protocol. So step 1 is isolate. This is my absolute value. This is what I need to isolate. So the first thing I'm going to do is add x to each side. So that will give me 2 times the absolute value of x plus 1 is equal to 4x minus 4. I need to get rid of this 2, so I will divide both sides by 2, giving me the absolute value of x plus 1 is equal to 2x minus 2. I've isolated my absolute value, and now it's time for me to split. So when I split this equation up, I'm going to have x plus 1 is equal to the right-hand side as it's written, which is 2x minus 2. I'm also going to write x plus 1 is equal to negative times, I have to take the opposite of the right-hand side, so that's negative times the quantity 2x minus 2. Really, really important that I put this inside parentheses. Now I'm going to go ahead and solve both of these. So in this case, I'm going to subtract x from each side, give me 1 is equal to x minus 2. I'll add 2 to each side, and I get x is equal to 3. When I work with this, I first want to distribute that negative in, so I get x plus 1 is equal to negative 2x plus 2. I will add 2x to each side, giving me 3x plus 1 is equal to 2. Subtract 1, 3x is equal to 1. Divide by 3, x is equal to 1/3. Now, I'm on my last step, which is check. So I need to go through and I need to check both of these solutions. Both of these answers need to be checked in my original problem statement. So let's start by checking x equals 3. So that's 2 times the absolute value of 3 plus 1 minus 3 is equal to 3 times 3 minus 4. I'm simplifying each side. Do not mix between the two sides. So over here, I need to deal with what's inside the absolute value. 2 times the absolute value of 4 minus 3. 3 times 3 is 9 on the right-hand side minus 4. The absolute value of 4 is 4, and 2 times 4 is 8. 8 minus 3 is 5. 9 minus 4 is 5. So that gives me a true statement. So I am all good. This is a solution. So x equals 3 makes my original problem into a true statement. Now I'm going to go ahead and check x equals 1/3. So when I'm checking x equals 1/3, I get, all right, 2 times the absolute value of 1/3 plus 1 minus 1/3 is equal to 3 times 1/3 minus 4. I'm going to kind of go through this pretty quickly. If you need help solving this, make sure you take your time and work through this. 1/3 plus 1 is 4/3. 4/3 is equal, or 4/3 minus 1/3 is equal to 1 minus 4. The absolute value of 4/3 is positive 4/3. 2 times positive 4/3 is 8/3 minus 1/3 is equal to negative 3. This gives me 7/3 is equal to negative 3, and that is not a true statement. So x does not equal 1/3. We call this an extraneous solution. It's a solution that appears to be a solution, but it actually isn't. When we work through our process, we get a value, but when we go back and check it, it doesn't work out. That's why this check step is so important. Sometimes you'll end up with 2 solutions in these cases, and sometimes you'll just end up with 1. So you need to make sure you check both solutions. We're trying to make true statements, and x equals 3 is the only value that makes a true statement in this problem.